Now trigonometry will start. Now we have a coordinate system, x-axis, y, x dash, y dash. This is called the first quadrant, both x and y positive. Second quadrant, third quadrant, and fourth quadrant. Now let us consider a unit circle on this. The unit circle is having a radius 1. A circle I have drawn, some circle. Let me take it as 1, 0, and here minus 1, 0. This is also 0, 1 and 0, minus 1. Now let me take a point like this is an initial one, 0 to A. Let me take a particle is moving in a circle. After some time, let me take it is at a point P. This point P is in quadrant 1. So this will have one coordinate like x, y. What is this x? So this point P, if you draw a perpendicular to x-axis, the distance of this is nothing but y, and this distance from the center O is x. Now this x, y is the point actually in our coordinate system. Now this point P with respect to origin is at an angle, theta. Now it is at an angle theta with respect to origin, the point P. If you join a line, point P from O, which is nothing but a radius, I can take it as 1. As because you have considered a circle as a unit circle, the distance from the point P to O is 1. Now we know from 10th standard, the sine theta, a trigonometric ratio, is perpendicular by hypotenuse. Cos theta is base by hypotenuse. Tan theta is sine by cos, if you do, that is perpendicular by base. These three ratios, basic ratios, we have learned from the class 10. Now you apply these things here. Now when I am trying to find the sine theta, this is perpendicular. What is the perpendicular over here? Perpendicular is y upon hypotenuse is 1. So y is equal to sine theta. And the same way, cos theta is base. What is the base? X upon 1. That means y is equal to sine theta, x is equal to cos theta. So the point P can be written cos theta, sine theta. This is a point on circle. P cos theta, sine theta is a point on circle of radius 1, that is unit circle. Now when if it is making an angle theta, now if we consider this cos theta, sine theta, we have considered as a point on circle and it is a unit radius. Now we consider the coordinate system. In the quadrant 1, both x and y are positive, and in quadrant 2, x is negative and y is positive. Quadrant 3, x and y both are negative. Quadrant 4, x is positive and y is negative. Now we know in the quadrant 1, as x and y are both positive, sine theta, cos theta, tan theta are all positive in quadrant 1. The reason, all are having a positive signs here. So sine will be positive, cos will be positive, tan will be positive. If you take in quadrant 2, that is, here y is positive, x is negative. Sine theta is y by 1 we have written. So now sine is y is positive, so that means sine is positive, but cos is base x upon 1. We have got x is negative, so that means cos is negative. So sine theta is positive. Sine theta is positive in Q1 and Q2. Cos theta is positive. Cos theta can be positive in Q1 and we're missing here Q1, that x should be positive. Q1 and Q4. Q1 and Q4. This generally we will be using a table or silver T curves. The all means sine theta, cos theta, tan theta and its reciprocal all are positive. Silver stands from S, sine theta and its reciprocal cosec theta are positive. T stands tan theta and cot theta are positive. And in the fourth quadrant, cos theta and sec theta are positive. Now, in class 11, we have cos A plus B and cos A minus B. These are the formulas. Of course, we have again sin A plus B and sin A minus B. Now, cos A plus B formula, cos A cos B minus sin A sin B, and cos A minus B is cos A cos B plus sin A sin B. This is y. Let me take this one. Sin A plus B is sin A sin B, sin A cos B plus cos A sin B. That means sin A sin B doesn't come here in sin. Why? This is also, we will put a question mark. This is again sin A cos B minus cos A sin B. Now let us derive sin B. Let us derive y cos A minus B. Y cos A minus B is equal to cos A cos B plus sin A sin B. This is proof that. Now, let us now again go to the unit circle. Let us draw a circle. I try to draw a circle properly for the first time. Let me take the point A is 1, 0. Here we have 0, 1, and here we have A dash. Let me take 0, minus 1. Make this is B at least. The B dash will be 0, minus 1. Sorry, this is minus 1, 0. Sorry for this. Now, let us take a point A, and here let me take a point P1, and here let me take a point P2. Let us suppose a point P1 at a distance, unit distance only, because we have taken a unit circle from the origin, but making an angle B. So when it is making an angle B, the P1 will be cos B comma sin B, as we have learned in the previous concept. Now P2, let us suppose this is making an angle A. That means it will be P2 will be cos A comma sin A. Now this angle A minus angle B will be something else. Angle A is of what? AOP2, AOP1. Let me say this one. AOP1 is angle B, AOP2 is angle A. I take a point in between, that is P3, which is making angle, like P3 makes an angle A minus B. So that means P3 could be cos A minus B, comma, sin A minus B. Now I join the chords. What are the chords I join? P3 to A and P2 to P1. P3A and P2 P1 are chords of same angle A minus B. Let me see again. Angle A is a full angle and B is up to P1. Then if you take out A from B, then the left will be angle P2O P1, that is A minus B. So the same way I have considered the point P3 is A minus B with respect to the origin. So they both are of same angle. If it is same angle, the chord's length should be same from the circle concept. Chord's lengths are same. Chord's lengths are same in the sense that means I can now write P1 P2 is equal to P3A. The distance formula. Let me take the distance formula. So here P1 is what I have assumed is cos B sin B. P2 is cos A sin A. P3 cos A minus B and sin A minus B, and A is 1, 0. P1 P2, the distance formula. I'll write x2 minus x1 whole square, that is cos A minus cos B whole square, plus sin A minus sin B whole square, equal to under root of I can write here cos A minus B minus 1 whole square, the distance formula only I am applying, and sin A minus B whole square. So you can do the squaring on both sides, then you can get rid of these square roots. Then I can expand this one, cos square A plus cos square B minus 2 cos A cos B. Along with that, this is sin square A plus sin square B minus 2 sin A sin B is equal to, here we get again cos square A minus B plus 1 minus 2 cos A minus B, and one more thing is plus sin square A minus B. As we know, cos square theta plus sin square theta and one side is 1. So here cos square A plus sin square A 1, cos square B plus sin square B 1, 1 plus 1 will become 2 minus 2 sin A sin B, as you can see here, minus 2 cos A cos B. Now we have cos square A minus B plus sin square A minus B will be 1. Already 1 is there. So it will become 2 minus 2 cos A minus B. I can cancel this 2 on either side. Minus will be multiplied on either side. So you can get 2 common here. Sin A sin B plus cos A cos B is equal to 2 into cos A minus B. So the 2 gets cancelled. I got the 2.